Okay, let's see the classification of these six elements. If you look at your periodic table, this element belongs to a particular group in the periodic table and a particular period. Let's know why these six elements belong to a particular group or period in the periodic table. Now we have letters there. These letters here are representing shell or energy level, and they are seven in number: letter K, L, M, N, O, P, Q. The numbers you see there as power are the number of electrons that each of these shell can accommodate. Like K shell will accommodate 2 electrons, L 8 electrons, 18, and so on and so forth. How do we know? How do we get these numbers? Okay, the numbers are gotten from this formula 2n squared. So 2n squared, okay, this n is the number, the integral numbers of this shell. So for K shell is 1. So 1 squared like this is 1. So 1 times 2. So maximum number of electron here is 2. So the number here is 2. 2 squared is 4. 4 times 2 is 8. So this is how we got this number. So now we're going to be looking at the electronic structure of lithium to know the group it belongs. So since the atomic number here is 3, so it means that in lithium, the first shell, which is a K shell, accommodates 2 electrons, and the what remain now is 1. So this element belongs to period 2, 2 shells. 2 shells will give you information about the period the element belongs. And then the valence shell is the L, which is 1. So this element belongs to group 1, period 2. Next element is sodium. Atomic number is 11. So K shell is receiving 2 electrons. L shell is receiving 8 electrons. Check what is remaining now is 1. 1. Okay. K shell, 2 electrons in the K shell, 8 electrons in the L shell, but not 18 here. The reason why put 18 because we have 18 in the M shell, it cannot add up. So what you will do, you go to this box. This box here, box 8 is without transition element, periodic table. With 18, that means it includes both. So what I will do now, I'll add these two numbers and have 10. 2 plus 8 here is 10. I will check. I will now know what is remaining now. If we have 10 already here, subtract that 10 from 19, you're going to have 9. So check these two numbers. Which number is close to 9? It's 8. So what should be here is 8. What should be here is 8, and you have 1 split in the N shell. So this element belongs to group 1, period 4. So for rubidium here, 37, we have 2, 8. Add these two numbers here. You have 10 minus 10 from 27, 37, we have 27. So check these two numbers. Which of the numbers appears to be close to 27? That is 18. So this will hold 18. So by the time you check now, you now see that 2 plus 8 is 10, 10 plus 18 is 28. If you subtract that 28 from 37, you now see that 9 is remaining. So now check these two numbers, which one is close to 9. The number is 8, then the one will now spill over here. So this element belongs to group 1, period 5. So now look at cesium here, as simple. So you have here 2 electron from 55. It can hold 8. Numbers are too many here, it can hold 18. But I doubt if it can hold 32. If you try 32 and add up, I don't think it will add up. You can use your calculator. So it's not going to add up. So what do? We add numbers. 2 plus 8 is 10. 10 plus 18 is 28. Subtract 28 from 55, and that will give you 27. So 27, which number is close to 27 here? 18. So what goes here is 18. So if you subtract 18 from 27 remaining, what we're having now is 9. And then 9, which number is 9 close to here? Is 8. So here you have 8 remainder 1. So it means that this element belongs to 1, 2, 3, 4, 5, 6, period 6, and then group 1. Try the last element. Bye bye.